Bismillah ar-Rahman ar-Rahim. Dear students, this is Professor Shafqat. This is the second lecture in the series of the lectures in the field of electronics. In my previous lecture, which was lecture number 1, I have talked about the difference between the electrical circuits and the electronic circuits. In that lecture, you have seen that we get a very good control over the flow of current in the circuit having the electronic components. Hope that you remember about those electronic components. In today's lecture, I am going to talk about those electronic circuit components families in a bit more detail. On the board, you can see that I have written 7 components, 7 electronic components. Simply, I will talk about these 7 electronic components. So, in every component, I'll talk about the 3 fields. Let's say if we start from the concept of the resistors. I will talk to you that how we can make the resistor and what is the very basic function of the resistor and in which type of applications normally we use the resistor. And same is the case for the other components as well. Hope that you can see on the board that if we talk about the capacitors, so there will be 3 things that I'm going to explain, mean about the making of the capacitors, and how we make the capacitors, the very basic function of the capacitor, and the normal applications of the capacitors. And so is the case for the inductor, and the 4th one component is the diode. The 5th one component is the transistor. Here you can see this is transistor. And the 6th one, very important component in the electronic circuit, is the transformer. And the last component, but the very important component is the operational amplifier, because in today's fields, industrial applications, you can see that if we are able to design the analog to digital converter, the digital to analog converters, the current to voltage converter and current voltage to current converters, are the integrators, are the differentiators. These are very advanced topics in the field of electronics. All those circuits are made from the operational amplifier. So operational amplifier is also one of the important component of the electronic circuits. So let's start from the very first component, the the resistors. Now resistor is a very basic component, electronic component of the electronic circuits. How can we make the resistor? So there are different types of the resistor, as I told you that these are not only components, but these are names of certain families. By families mean, if I'm talking about the resistor, so there are different types of resistors. If we talk about the wire wound resistor, so the making of that resistor will be different. If we talk about the carbon resistor, the making of the carbon resistance will be different. And if we talk about the solid state resistors, so the making or the fabrication of that type of resistor will be totally different. So, but simply if we talk about a simple type of resistor, so its making is, if we take a wire, so every wire is having some resistance. So if we take a core and if we take some turns of the wires through a core, so we can increase the resistor of that wire. That may also become the inductor as well. Here this one is the inductor, but we can increase the resistance of the wire if we increase the length of the wire. So this way we can also increase the length of the wire. And as you know that the very basic function of the resistor is to limit the current in the circuits. In my yesterday lecture or in my previous lecture, if you remember, I have talked about the resistor. If you don't connect the resistor in the circuit, so a huge current with a very high speed, hope that you remember about that value, 270,000 km per second. That speed of electron when passes through a wire, so every wire is having certain capacity, current carrying capacity. So that huge current is basically burn the wires. For that purpose, or if you connect some components in the electronic circuit, so it may burn those components as well. In order to protect the components as well as the wires, we connect the resistor in series of those components, and it used to limit the current. So the very basic function of the resistor is to limit the current into a certain range, so that we protect the components as well as the circuit. Applications of the resistors are, especially it may take from its functionality because it's used to limit the current, but we use the resistor in combination with the capacitors in order to make the RC time constant circuits, or the other types of the filter circuits, and we may use the resistor along with the inductor and the capacitor in order to make the filter circuits. So, and there are much more applications of the resistor. Next, if we talk about the capacitor, what is the making of the capacitor? In the capacitor, we basically take two plates. There might be metal plates, or there might be some other material, and when we put some dielectric material in between the two plates, so we can make the capacitors. And making of the capacitor is this much simple process. But what is the very basic function of the capacitor? The very basic function of the capacitor is to store the charges. So the very basic function of the capacitor is to store the charges. Now if it can store the charges, so the application of the capacitor is used in just like charge storage banks. And as I told you earlier, that if we use the capacitor along with the inductor and the resistor, so we can make the filter circuits. And normally we use the capacitor in the power supplies in order to eliminate the ripples. Ripples mean the varying factor of the DC sources, so that we are able to get a steady state smooth DC for the DC components in order to operate it properly. So we use the capacitor in those cases as well. So capacitor is just like a money banks in our society. Whenever we have a huge amount of money, and if it is above the requirement of us, so we put the money in the bank, and whenever we require some amount of money, so we go to the bank and retrieve that required amount of money, so that we should run our daily life. This same is the case of the capacitor in the circuit. It is used to hold the charges, and whenever those charges are required, so this capacitor basically releases some portion of their charges to the circuit in order to make the function properly. I'm talking about these components in a bit in a simple way, not in that much detail, but later on we will have some more discussion about the capacitor as well. Next component what we have in the electronic circuit, that is called inductor. Now making of inductor, as I told you, that the making of inductor is a very simple process. Take a simple copper wire or any metal and then make some turns of that wire. When you will make a turns of that wire, so it will become an inductor. So this is the process of making the inductor. The function of the inductor is mysterious. I will talk about that mysterious phenomena later on, but let me talk about the very basic function of the inductor. The very basic function of the inductor is to oppose change in current. The very basic function of the inductor is to oppose change in current. By oppose change in current means, let's say current is moving in this direction, and if current want to increase, so it opposes. If current want to decrease, so it opposes. So if there is a variation from a steady state or the normal state, that variation is get opposed by this inductor. So it opposes the increase in the current as well as decrease in the current. So it is why it is also used in the application like the filter circuits. And in the radio circuit, in the very old radio circuit, we used the inductors. We have seen the inductors and the capacitor. If you change the value of capacitor or the value of inductor, so what you see actually, you change the reception frequency filter. Okay, so what type of frequency you want to filter out and what type of frequency you want to receive. So that can be done by changing the value of the capacitor or the value of the inductor. Next component is the diode. So we are now exactly into the electronic circuits. Diode is a semiconductor device. Before the diode, in the electronic circuits, we were having the electrodes like triodes, the pentodes, and something like that. And that technology, in that times, we were using the technologies like vacuum tube technologies. But once we were able to design the solid state diodes, so then the size of the components start reducing, and it also brings some revolution inside the electronic circuits, because these type of circuits are now more sophisticated, more good, more small size circuits. Okay, so we can by the use of these type of diodes, we can make a bigger circuits with this. So now what is the very basic formation or the making of the diode? As I told you that these are now a very advanced components, so making process, I will simply talk about the making process, but the concept of the diode requires more lectures. Okay, so simply mean diode can be made from the two p-n junctions, like one p-n junction, and there will be two materials, n-type material and p-type materials. Once we bring the two materials into a contact, so it makes a p-n junction. This is called a p-n junction. This p-n junction is then make a diode. So here you can see that this is the positive side and this is the negative side. So diode symbol looks like this. This side shows the cathode, this side shows the anode. So we basically make this type of the diode. Now, what is the very basic function of the diode? It allows current in this direction from anode toward the cathode, but it blocks the current in the opposite direction from cathode side toward the anode side. So it blocks the current. When it blocks the current, so if you look at its very basic function, so then you can realize the applications of the diode. Now, the very common use of the diode is to convert the alternating current sources, in which we have positive cycle as well as negative cycle. So if you connect this signal with the diode, so positive cycle will be able to pass through the diode, whereas the diode will block the negative cycle because it is coming from the other way around. So it will block it, and this way we will be only getting the positive cycles. So now we are in the one polarity only, so we can convert the AC signals to DC signal by the use of the diodes. So in other words, we may normally use a diode in the rectifier circuits, because rectification is the process of converting the alternating current or the AC current into a DC current. As I told you in my previous lecture, that electrical signals are AC signals. By and large, these are AC signals, whereas electronic signals are DC signals. So whenever we connect the power source with the electronic gadget, so we connect the 220 volt, but inside the electronic gadget we are having a power supply which converts the AC signal to DC signal first, and then it is given to the different parts of that electronic gadget. So in that type of power supply we are having the diodes, and we will talk about those concepts later on when we will reach to that topic. So diode, the very basic application of the diode is the rectification, conversion from alternating source into a DC source, and there are much more applications, but I am talking about the very basic type of the applications of the diodes. Now let's talk about the third type of component, which is called the transistor. Transistor is also a very important component. The making of a transistor is done by use of the two diodes. Let's say you have seen that in the diode we are having two plates. One is the N plate, another is the P plate. As I mentioned you that it's N-type material and P-type material. How these materials are constructed or how it is basically formed, we will talk about that in some other lecture. But we can see that diode can be formed by the two materials, N-type and P-type, whereas in the transistor we are having the three materials. One is the N-type material, and in the center we may have the P-type material and the N-type material. There is another type of the transistor as well, in which we may have P-type here, N-type here and P-type here. So if we talked about the BJT type of the transistor. There are some other types of the transistor like the MOSFETs. In that we have a different arrangement of these materials, but here we have the N-type material, P-type material and N-type. So this type of transistor is called NPN transistor. If you are having P material, N material and P material, if N is sandwiched between the P materials, so that will be called PNP type of the transistor. If P is sandwiched between the two N materials, so that type of transistor will be called NPN transistor. And these are called BJT type of transistor. BJT means bipolar junction transistor. The very basic function of the transistor is to amplify the signal. By amplification means that it can amplify the voltage signal or it can amplify the current signal. By amplification means when we give the smaller signal to the transistor, it can increase the amplitude of that signal and it adds some extra energy with that signal without affecting the frequencies and the phase of that signal. It basically aids the energy with that, so we get the more powerful signal and we are able to receive the powerful signal through the transistor. The transistor is used to amplify or to magnify the signal. Applications of the transistors are that if it is used to amplify the signal, so you may use this type of signal in the amplifiers. Let's say if you use a single transistor, we can make a single transistor radio as well. If we connect here the speaker or the headphones here, let's say these are the headphones, and here is the supply, battery supply. Let's say this is 3 volt, this is ground, and if you connect the input signal, let's say this is the antenna, and you connect the antenna here. So if the antenna gets the signal and it is connected with transistor, there will be some beta or the gain factor of the transistor, let's say it is 100. So it will amplify the signal, and that amplified signal is further connected to the headphones. So if you connect the headphones in this fashion, you will be able to hear the sounds. Of course, some 1 or 2 more components we are required to connect here so that we change the frequencies and we able to receive the different types of channels. So the very basic application of the transistor is to amplify the signal, and it is used in the amplifiers. Next is the transformer. Here you can see that the component number 6 is the transformer. Making of transformer is from the inductors, because if you take a coil as a primary coil and you take another coil as the secondary coil, and we basically make this turn across certain core, so we are able to make a transformer. If there are more turn in the primary coil and if there are less turn in the secondary coil, so this type of transformer is called step down transformer. The function of the transformer is to change the signal strength, to change the signal level. If we are having a high voltage signal, so we can convert that high voltage signal into a low voltage signal without changing its phase, without changing its frequency, and it will remain without changing the type of the signal even. We will be able to step down the signal from the higher one to the lower one if it is step down transformer. We may have some transformer with less number of turns in the primary and more number of turns in the secondary. So if we have this type of transformer, so this type of transformer will step up the voltage from the lower to the higher volt, and this type of transformer is used inside the inverters today, in the UPSs and inverters what we have in our homes nowadays, because 12 volts are connected to the primary, and then it gives us the higher voltage, which is the 220 volt, and further we connect the 220 volt with the AC load. As I told you, that the very basic function of the transformer is to change the amplitude or the strength of the signal. It is not like a transistor. Actually, transistor is having some different purpose. It is amplifiers, whereas it's basically step down the voltage or step up the voltage. And the applications of the transformers are in the power supplies mostly, because as I mentioned you that once we connect the 220 volt to our electronic gadget, so it gets that 220 volt in some of the transformer, which is called step down transformer. It converts the 220 volts into maybe in some cases to 12 volts, and in some cases to 5 volts, in some cases to 15 volts. All those voltages will be the AC sources, and it is further connected to the diode, so it converts the AC signal into DC signal, and then The other voltage regulators and the filter circuits are used to make it smooth DC, and then it is given to the electronic equipment. So these are all in this whole process the transformer is used. Now the last component what I am going to explain is the operational amplifier. The making of the operational amplifier, as I told you, it is a very huge subject. Okay, so I'll not be able to explain it here, because in one operational amplifier there are 27 number of transistors. When we use 27 number of transistors, we can make one operational amplifier. And operational amplifier is one of the type of the amplifier having 4 stages, having 3 stages actually, but there are 2 supporting stages, like the biasing circuitry and the circuit protections, short circuit protection. So we have the 5 stages anatomy in the operational amplifier, and there might be one complete course on the operational amplifier. And the function of the operational amplifier is, I may tell you about the function. This transistor is used to amplify the signal. This is also used to amplify the signal, because it is, as it is evident from its name, that it is an amplifier. But operational amplifier can lift or can increase a very weak signals. A weak signals like a signal in the nanovolts range, microvolts range, millivolts range, and it is required in the practical circuit. Why? Because if we connect the ECG machine with our bodies, different nodes of our body, so those sensors basically pick up a very weak signal from the body, and we are required to amplify those signals in order to process the signal. Or if we connect the EEG machine on our skull at different nodes, so it pick up the alpha rays, the beta rays, the gamma rays, in order to know the different mild signals, and then we are required to process the signal for different assessments. Okay, so in that case we also get very weak signals, and there are much more type of sensors which pick up the very weak signal from the physical world. Then we are required to lift or to increase the signal. In that case we use the operational amplifier, and there are many examples, application example of the operational amplifier. As I told you in the first part of my lecture, that operational amplifier may be used in the voltage to current converter, or current to voltage converter, or digital to analog signal, or analog to digital signal, or potentiometer, or maybe inside the integrator or differentiator. And there are many examples of the operational amplifier component. So finally I will summarize that in this lecture I have talked about the 7 components or the 7 families of the electronic circuits, and I have talked about the making, the function and basic applications of all these components. We talked about the resistor, the capacitor, the inductor, the diodes, the transistors, the transformers, and operational amplifiers. So that's all for today's lecture. Hope that you will learn from this lecture. So if you think that you have to learn some more topics related to these type of concepts, so I would request you that please ask me in the comment section, so that I should be able to make those lectures for you. I thank you all. God bless you. Thank you very much. Allah Hafiz.